Hello learners, welcome. Previously lesson 2, we were dealing with bond breaking and bond formation in physical and chemical processes. Lastly, we were dealing with bond breaking and bond formation calculations. We have done example 1. Then today, lesson 3, we are starting with lesson 2 on bond breaking and bond formation calculations. Okay, the question is, we are told to study the information in the table below and answer the questions that follow. So this is how the question is, the bond breaking and bond formation. So we have the bond here and the bond energy in kilojoules per mole. So carbon to hydrogen bond has a 414 kilojoules per mole. Then here we're having chlorine to chlorine, carbon to chlorine, and hydrogen to chlorine bond, and they have their bond energies there. So the question is, we are told calculate the enthalpy change for the reaction. So for you to get enthalpy change of the reaction, the formula is, first of all, if you want to get enthalpy change of the reaction or energy change for the reaction, you are supposed to have the bond breaking energies, then you add bond formation energies. So in bond breaking, we are told it requires energy, so that's an endothermic reaction. So we are going to have a positive sign, and bond formation releases energy to the surrounding, therefore it is an exothermic reaction. So here we are having bond breaking side, so the reactants, we are having bond breaking. In the product side, we are having bond formation. So first of all, for you to know now your bonds, it is good, or it's encourageable for you to break your bonds or to write this gas, that's methane, in open structures, so that you see the bonds that are there. So carbon is having 4 hydrogen bonds, plus chlorine gas is having chlorine to chlorine with a single bond. That's the bonds that you have in the reactant side. So here you have carbon to hydrogen bond, which are 4 in number, 4 of carbon to hydrogen. This 4 is 1 here, then 2 here, 3, then this 4. That means carbon to hydrogen, we're having 4 times. Okay, here chlorine to chlorine is only 1 time, we're having like that. So 4 times, what is the bond for carbon to hydrogen? It's 414 given in the table. So plus chlorine to chlorine here is 244. So 4 times 414 plus 244, we are going to get 1900 kilojoules. Okay, let's go to bond formation. On the product side, you're having chloromethane. This chloromethane, CH3Cl, which is a gas, plus hydrogen chloride gas. This is a substitution reaction, and we're having the UV light or ultraviolet light. Okay, so here you're having carbon, which is bonded to 3 hydrogen atoms, and also chlorine. And here we're having hydrogen bonding with chlorine, hydrogen chloride gas. So here, carbon to hydrogen is we are having 3 carbon, hydrogen, carbon, hydrogen, carbon, hydrogen. So 3 of carbon, hydrogen, plus you're having carbon to chlorine of 1, then you're having hydrogen to chlorine, which is 1. So 3 times carbon to hydrogen, the bond energy here for carbon to hydrogen is 414, plus carbon to chlorine, this is carbon to chlorine, 326, plus then you're having hydrogen to chlorine down here, 431. So if you sum up all this, you're going to get 1999 kilojoules. Okay, so how are we going to get our enthalpy change or energy change or heat change? You're going to get by having bond breaking energy plus bond formation energy. So remember, bond breaking energy is an endothermic, so it has a positive sign, plus then bond formation energy is an exothermic, so it is supposed to have a negative sign. So if you add this, you're going to get negative 99 kilojoules per mole. So this will be the enthalpy change for that reaction, which is here. Okay, number 3, we are told use the bond energies provided to determine the enthalpy change for the reaction represented below. So we're having ammonia gas decomposing to produce nitrogen gas and also 3 of hydrogen gas. Okay, so for us to do this, we are supposed to have, first of all, where to do the question. So first of all, you are supposed to have your bond breaking, and remember, bond breaking will be the side of the reactants. So there we are going to write bond breaking. So in this bond breaking, we have ammonia. So ammonia can be written NH. So it's having 3H, but we have 2 to balance the question. We are supposed to put the 2 there, but it is the multiple of all. Okay, that's bond breaking. So to simplify it, we are going to have 2 bracket, then I'm having 3 of nitrogen to hydrogen bond. Check. Nitrogen to hydrogen, nitrogen to hydrogen, nitrogen to hydrogen. So that's now 3 of nitrogen to hydrogen bond. Okay, let's move. Then next, let's get now the energy for that bond breaking. So we're going to have 2 times 3, those are 6. Then open bracket, we are going to have or to see the bond for nitrogen to hydrogen. That's 388. So 388. So here I'm going to get a value of 22 kilojoules, 28 I mean kilojoules. So that's my bond breaking side. So I'm going to go to bond formation side. Okay, we are going to go to bond formation. We said bond formation energies we check from the product side. So what do you have from the product side? You have nitrogen gas. So nitrogen gas, we are going to have nitrogen to nitrogen triple bond plus we're having 3 of hydrogen gas. Hydrogen to hydrogen will be a single bond. So nitrogen to nitrogen bond energy will be, if you check, 944 plus 3 open bracket. What about the energies for hydrogen bond? It's 436. It is written here, hydrogen 436. So 944 plus. So here when you multiply this and you add all this, we are going to get a number of 22 and 52 kilojoules as the energy there. Okay, to move, we are going to get the heat change or the enthalpy change. So enthalpy change or the heat change is given by bond breaking energy plus bond formation energy. Okay, this will be equal to the bond breaking energy is 28 kilojoules, but you're supposed to put positive because that is an endothermic process. Then plus, then this is 52 kilojoules, but it's bond formation, that means it releases energy, so it's an exothermic reaction. We are going to have minus 52. So when you add all this, you are going to get positive 76 kilojoules per mole. So that will be the energy change or the enthalpy change for that decomposition of ammonia to form nitrogen gas and 3 moles of hydrogen gas. Then next, we are going to go to question number 4. Question number 4, we are told use bond energies given below to determine the heat of combustion of methane. So methane is written CH4. Okay, so what are we going to get? First of all, the reaction is here, methane plus 2 of oxygen gas. We are going to get carbon dioxide and also 2 mole of water. So let's just try to have our bond breaking energies. So bond breaking energies. So bond breaking energies is gotten from the reactant side, and in the reactant side we have methane. So if we write that in open structures, we are going to get something like this: methane plus oxygen, 2 of oxygen. Oxygen to oxygen is having a double bond. So what does this mean? That means I'm having 4 of carbon to hydrogen bond plus 2 of oxygen bond. So let's get the bond energy there. So I'm having 4 bracket. What will be the bond energy for carbon hydrogen bond? It's 412 plus. What about the oxygen double bond? We're having 496. So if we add this, we are going to get 2640 kilojoules. That will be our bond breaking energies for that reactant side. So we want to go to the other side, that is the bond formation energy. Bond formation energy, and this one we can get it from the product side. And you see product side we're having carbon dioxide. How do you write carbon dioxide? Carbon dioxide is written like this. So plus I'm having water but 2. So how do you write water? Water is written OH then H. Okay, so if we simplify this, we mean 2 of bracket carbon to oxygen. That's carbon to oxygen. This is 2 of carbon to oxygen plus. Then here we're having 2 and it's oxygen hydrogen. So it will be 4 of oxygen hydrogen. Okay, let's go 2. Then what is the bond energy for carbon to oxygen double bond? It's 803. 803 close bracket plus 4. What about oxygen to hydrogen? Oxygen to hydrogen, that's 463. So here, what are we going to get? Here, we are going to get 3458 kilojoules. So next, let's go and see if you want to get enthalpy change or heat change of a reaction. What is the formula? The formula is bond breaking energy plus bond formation energies. Okay, remember we said bond breaking energies is an endothermic reaction, so we are going to have a positive sign, so 2640 kilojoules plus, and bond formation energy releases energy to the surrounding. That means it's an exothermic reaction, so we are going to have negative 3458. Here the net energy that we are going to get is negative 818 kilojoules per mole. So that will be the enthalpy change for that combustion of methane. Okay, that's the end.